Hey guys, welcome back to the channel. I'm LeetCode. If you guys are new here, I pretty much do LeetCode style questions and explain things in the simplest way possible. Today we have a pretty interesting problem that I'm very excited about. So let's go ahead and read the problem statement. So the problem's called closest binary tree value, right? So it says that given the root of a binary search tree, right? Binary search tree, okay? And a target value, right? It says return the value in the BST, right? That is closest to the target, right? So we're going to be giving a target value, guys, right? And our job, right, is to pretty much return the closest, the node, right, that's closest to the target as possible, right? So you guys can see, right, we're giving this binary search tree, right? And then we see that we're giving this target, right? The target is 3.714286, right? The closest one to that number, right, is definitely 4, guys, right? The root node, right? Because 3 is not as close to it, right? 3 is like 0.7 this, right, away from it, right? And then 4 is, pretty close, is a lot closer, right? Less than 0.3 away from it. So that's why we end up going with 4, right? I didn't mention the other ones because they're obviously not closer to that number, 3.7142, right? So that's why I didn't even mention them, right? So this one, right? And by default, it's going to be 1 because there's no other nodes to compare it with. So 1 will be the node that will return, right? That's the closest one to that number that we got, right? So it kind of makes sense. So yeah, guys, so you guys know the way we're gonna pretty much solve this problem is gonna be very, very intuitive, guys. So it's gonna be very, very, yeah. So what we're gonna do, right, we're pretty much, guys, we're pretty much gonna traverse the tree, right? And as we're traversing, guys, we're pretty much gonna be comparing ourselves. So pretty much we're gonna pretty much calculate the difference, right, at every node that we visit, right? And then we also get this this instance variable, right, to keep track of the node that's closest to that target as possible, right? So every node, right, we calculate the distance, right, the difference, right, which is the distance that that node's value, right, is to that target, right? We calculate the distance, right? If it's if it's less than the closest we've seen so far, right, we update that node to equal to that node value, right, to equal to that node, right? So we calculate the distance, right, 4 to that 3.7, right? It would be like point something, right? Point like 0.2 something, right? So we would pretty much keep comparing every time, right? We go to 2, we check the distance from this, right? If it's less than it, then we update that node to equal to this one, right? But it's not less than this. The distance is not less, right? So we keep continuing. So 4 is still the closest one that we've seen, right? So that's how we do it, guys. It's very, very intuitive. So we have an instance variable, right, to keep track of the closest one. We calculate the distance of that node's value, right, to the target value, right? And if it's smaller, then we update that. If it's not smaller, then we keep traversing everywhere, guys. We keep traversing the tree, guys. So we're not. So since we're giving a binary search tree, guys, we're not gonna blindly search the whole tree, guys, because the tree can be huge, right? So I know it looks small here, it doesn't make a difference, but the tree can be a lot of nodes, right? So we need to efficiently use the property of a binary search tree, guys. So we can easily so we need to use the property. So we know that it's sorted, it's organized, right? They're sorted in non-decreasing order, guys. So what can we do, right? If the target that we're looking for, right, if it's less than the root, right, the root, right, whatever node that we're at, right, we keep searching on the left side, right? If it's not less than that node, right, we're not even gonna bother searching on the left side. We're just gonna search on the right side, right? We're just gonna keep searching. So we're not gonna blindly do it, guys. We're gonna use the properties of the binary search, all right, to know which side should we continue searching, right? Because you know we're not gonna waste our time by searching places where we don't need to, right? So if it was a binary tree, right, if it wasn't a binary search tree, then we would need to pretty much search the whole tree, because it's not a binary search tree, right? Binary search tree, everything on the left side is smaller than the root, right, and everything on the right side is greater than the root, right? So that's where we can kind of use the method that I just proposed just now, right? So let's go ahead. Hopefully you guys were able to understand my thought process. So let's go ahead with that real quick, right? So pretty much, guys, I told you guys I'm gonna have an instance variable to help me keep track of the node, right? So pretty much we're gonna call that closest, right? And yeah, so the closest, right? So pretty much you can call it closest node, right? Right, closest node, right? We call that closest node, right, is equal to so initially is going to equal to the root node, right? To handle the case where that node, right, is the only node in the tree, right? We pretty much return that, right? So we're going to use an helper function, guys, to pretty much helping us in doing that, right? And so pretty much we're going to pass in the target as well, right? And in return, guys, the closest node, right? We need to return the value, guys, the value of that node, right? So pretty much, guys, what we're doing, we're here, we're simply going to, we're not returning anything, so it doesn't matter. So so we're going to be passing in the tree node, root, the double target, right? So we know our base case. We're pretty good now with the recursive stuff that we do here, right? So if root is equal to null, right, we return from our recursive call, right? And then, guys, I told you guys we keep checking every time, guys, right? So we do so we calculate the distance at every single node, right, that we visit, guys. So yeah. So root that val, right, minus, right, the target, right? So pretty much that's how we get the distance, guys, the distance, you know what I'm saying? So we do the absolute value, guys, because we know we want to get the absolute value, right? We want to get the distance, right? We don't want to get a negative value, right? So yeah, so that handles that case, guys. So just like we compare it now, so right now what I'm doing, right? So I compared that current node that I'm at right now, right? I calculate the distance, right? If it's smaller than the closest, right, closest node so far that I've seen, right, minus if it's smaller than the closest node to the target, right, that I've seen so far, right? If its distance it's smaller, right, than the closest node's distance from the target, then we update that node, right, to equal to the current node that I'm at right now, right? I get the reference to it, right? So it gets updated, guys. So to that, right? So since this one is a closer one to the target than the closest one that I had, right? So that's why it gets updated, guys. So for you guys to be able to get that, it's a very, very important thing that you guys understand, right? So that this is where we're gonna decide, guys, where to keep on searching, guys. So we're not gonna waste time at all, right? Okay, so what we're gonna do here, right, we're gonna see if root val, right, is greater than the target that I'm looking for, then, guys, I'm simply gonna be searching on the left side, right? Right, same thing, right? And then right here as well, right? If it's not small, if the target is greater, right, we simply go on the right side, right? We pass in the target as well, right? Yeah, we should be pretty good after that, right? So let's check if we pass the small test case, guys. Nice. Seems like we passed the small test case, guys. So it says yeah, so let's press submit. Awesome, guys, we're able to pass all the test cases, guys. So I want to thank you guys for taking the time to watch the video. If you guys found value, make sure to give me a like. If you guys are new here, subscribe to the channel, because we have a lot of fun here. We do a lot of those questions here. And yeah, so thank you guys for watching, and I'll see you guys in the next one.